Yo, what's up? Today we'll continue our machine learning course. So we will learn a new algorithm called um, KNN algorithm, aka the K nearest neighbor algorithm, to predict how old a abalone is. So basically, it's like how much ranks they have. It's basically how old they are. So like this one's 15, this one's 7. And we will just like, first of all, we will simply just, wait, let me put these here first. I'm pretty sure these are the ones that's for the decision tree classifier. Alright, so let me just put them here. Oops. Alright, I think this is fine. So first of all, we will wait. So wait one sec. Yeah. So basically, this line just like using pandas to read the CSV in, and how you find this path is basically you press this after downloading this CSV. You can basically like go here or go to your file and open download to see the path of this CSV, and then basically just read it in with pandas. So first of all, we will use, right, these are the, actually, yeah, these are the libraries that we will need. So first we'll draw a scatter plot. Wait. So first we will see how like this, how the age of these abalones are like distributed, and we will just draw a histogram plot. Oh wait, shoot, I forgot to do this. plt.show. Basically, the like data ranks, it just this whole column, and then we'll use it to draw a histogram plot, and then like using this line to just show it. Yeah, so basically it just means there's about like 1,600 that's like I guess 8 years old, and 1,400 that's like about 11 years old, and like yeah, this is just how much it's like how much of the ages of the abalone there are. So there's like barely any abalone that's like 25 years old, and barely any that's like 2 or 3 years old. They have a pretty short age span compared to human. Alright, so now we know basically like the distribution of the abalone. We're continuing. Let me draw a scatter plot. And a scatter plot in two variables. One is the x and one is the y. So y will just be the age, and x will be I'm pretty sure it's the total diameter. No, it's just diameter. So we'll just see like how does the diameter have a relationship with the age, and it's like pretty straight. Like you can see that the bigger the diameter, the older it is. Now let's see the weight. I'm pretty sure this will also have like a, yeah, it also have a pretty like significant effect on how old it is. So like basically the heavier it is, the older it is. But today, we will use this thing called KNN. So KNN model will just equal to K neighbor classifier. So K neighbor classifier is based on, it's not really like it's like a classifying model. So like let's say we have this new data. It's like length 0.455, diameter 0.365. At this height, this weight, and the classifier would just um look at the groups that have the most similar data us, the one that we want to predict, and basically like use it, and we'll like just add neighbors, and this will be, it will usually be odd, so it can like break even, because if it's even, then like if there's like two opposite data point, then it'll be like very annoying, since like because like each data point have the same weight, so it would just be a bit hard to deal with. So that's why we usually have like odd amount of data points. So this is like basically let's say you look at this like random person, and then how you think they like, how good you think they look like might be like based on your friend. Like you just take your three friends that look the most similar as them, and like give this random person the same like how good they look as the friends that you actually know. I don't even know if I explained well, but like yeah, it's like that's basically the point. So if I have the uh like data of one, like if its data is one, they will also look at like the like training set that have like the data that have most similar data to it, like maybe one, maybe two, maybe like zero, and then if like maybe this one equal to A, two equal to like B, and then this equal to A, then it will probably assume one will also be A, because this is like the most similar data. And and this a neighbor, just like how much neighbor have. Usually we want to have a odd number as our neighbors, and also the neighbor, usually we want it to be like small, because if it's like really large, and I will use a lot of data points that's not even relevant to the data that we want to predict. And data equal to data, the drop. I'm pretty sure it's like x, and axis equal to 1. Basic just dropping this column, because we, first of all, it doesn't really matter that much. Second of all, like this only takes in numbers as their input, and x train, x test, y train, and y test equal to train test split xy, and test size equal to, I would say, 0.2, and x will just be equal to data dot drop. What will it drop? Just rings, and axis will be equal to 1, and y will just equal to data rings. So so these are the sets that we need to use to train our data and like to test our data. And so like how much, this is just basically how much test there are, which is 20%. And this just being like this, the x is what we want the model to like know, and the y is what we wanted to predict. So the y is like the age which we wanted to predict, and then the x is everything beside the age, which is the attribute that it will know. And then now we'll use the model dot score. Wait, no, model dot fit. Pretty sure it's x train and y train. And then model dot score. So accuracy. You could model dot score x test and y test. And then we'll print out accuracy. So it's like these, like right now, are always like pretty simple. What it's like hard is like you know modify the data so that our model can actually understand the data. This is why for the one we did before, which is the decision tree classifier, it spends so much time, but this is like very quick. So I have this accuracy of 22%, which is very low compared to the one that we did on the car for the decision tree model, which is like 90 something percent. And the reason is because for the last one, we only have like 0, 1, 2, or 3 as our output, which is like 4. But for this one, the output have like more than like 25 outputs, so it will be really really hard. And like even if it's off by like 1, it will still be like wrong. So this is why I have a pretty low accuracy. And now let's say we use a neighbor as like 1, like what will it be? 0.19, only 19%. That's pretty low. What about 100%? I mean 100, like 27. Damn. Yeah, like this might be because like every variable is like kind of related. That's why like we usually use it as a lower number, which is 3. Alright, let's see how decision tree classifier will do. Decision tree classifier, what will it be? Damn, only 19%. That's like worse. Because like K-nearest neighbor is like a, in my opinion, it's a better algorithm than decision tree. Now we'll just draw the heat map. Oops. So I'm pretty sure it's, oh wait. So import Seaborn as SNS, the heat map. So we'll predict equal to model.predict x test, y test, and then predict. Wait, no, is it? I'm pretty sure it's x train, right? And then predict, and then y test. Kind of forgot. And then we will just use plt dot Oh my god, I forgot these. Let me see. Oh, it's confusion matrix. This is white train. Confusion matrix. Wait, what? Alright. Is it cut? Oh, it's from SK Learn. So we also, wait, don't I already have this one? So, wait, what? CM, oh, my fault. CM equal to confusion matrix, SNS dot heat map, confusion matrix, and then annotation equal to true. True is capitalized, and PLT dot show. So this is a pretty good visual for like how accurate the K nearest neighbor classifier is. Well, let me see what's the error. It's CM, not confusion matrix. Now it should work. So in the diagonal, it's what is correct. Like if it predicted 0, it's actually 0. When it predicted it's 2, it's actually 2. When it's 1, it's actually 1. So the diagonal is what we want it to be like correct, and the rest it's what's like wrong. But like there's a lot of data that's like really close. So I will give you guys like a homework is that try to make it like that if the prediction value is like in the range of -2 and 2 compared to the actual value, we'll view it as correct. And this is basically the K nearest neighbor classifier. And thanks for watching. Bye.